Hello everybody. In today's video we're going to take a look at solving a differential equation using the method of separating the variables. Okay, so here's the example we're going to take a look at. dy dx is equal to minus x divided by y, and our job is to find y, which is a function of x. Okay, so what do we need to know? Well, it's a first order differential equation because the function y has only been differentiated once, so this is a first order differential equation. And with the separating variables, what does this mean? Well, it means that we can write dy dx as a product of two functions, and in each of those functions the x and the y has been separated. So we can see here f of x, this is just loads of x's put together in various ways, and here all the y's put together, which can also be done in various ways. So if we can do this, it's not always the case, but if we can split these variables, then what we should do is collect all the y's on the left hand side. So I'm going to move all the y's in the green circle to the left hand side, just divide them through, and keep all the x's on the right hand side, and then integrating both sides with respect to x. We see something quite useful happens, that, well, let's do it. So I'm just integrating both sides with respect to x. Well, the right hand side, we just need to calculate that integral. How about the left hand side? Well, the x's cancel and I'm left with some integral with just the y variable. Okay, and from that I'm going to get some y, and I'm going to, depending on the situation, isolate the y function. Okay, so how about our case? So we have minus x divided by y, and we want to separate those x's and y's. So how can we do that? Well, we could write it as x times minus 1 over y. This way the x's and y's are separated. Or we could do minus x times 1 over y. Both of them are fine. Okay, so the next step then would be to put all the y's on the other side. So I think I'm going to use this one, and I'm going to multiply through by y. I get y dy dx equals minus x. Okay, so that's the first step, if you like. The second step is integrating both sides with respect to x and then isolating y. So let's do that next. Let's do that on a clean page. So we have y dy dx is minus x, and I'm going to integrate both sides with respect to x. Okay, so the left hand side, integrate this, just like that, and the right hand side, you can integrate that, it's just minus x. As expected, those dx's are going to cancel there, so integrate y with respect to y. So standard integral, go upper power, divide by the power. The right hand side, integrate minus x with respect to x. It's another standard integral, So we've upper power divided by the power. And we need a plus c. And I suppose we could put them on both sides after doing integration. The convention is to just add the c on the end on the right hand side. Okay, so we now have an equation with our answer y in there. So if we study this one, I don't think it's going to look too good if we get y on its own. It might involve some square roots. So I'm just going to simplify a little. I think I'm going to bring this term over to the other side. So there's a plus. And I think I'm going to times through by 2 just to get rid of those halves. So I'm going to write this as x squared plus y squared equals 2c. And I think I'm going to label 2c as something else. I'm just going to call it maybe a different letter. Let's just call it a, where a is a constant. Okay, so there's my answer. X squared plus y squared is some constant a. I could rearrange it to get y on its own, but I don't think it looked that nice. I think this really shows the relationship. For the answer y, just absolutely fine. So what do we notice geometrically? Well, for different values of a, we're going to get circles of varying size. Size would be measured by the radius. So for example, if that constant a was 1, we'd have a circle. It's going to be centered at 0, and the radius is going to be 1. Similarly, if higher values of a, if we choose say 4, then we're going to get a circle. This time the radius is going to be 2, because the equation, the general equation of a circle, x squared plus y squared equals r squared, the radius, and so on and so on. Different values of a are going to give circles all centered at 0 with radius, in our case, with the square root of a. So there you go. There's our first example of solving a differential equation using the separating the variables method.